Hello everyone. So welcome you again to the lecture number 21 of chapter number 8, and in this lecture we will solve a question from your NCERT textbook, that is example number 5. So let us understand the statement of example 5. So it is given that so that the bisector of angles of a parallelogram form a rectangle, right? So here we have to first draw a parallelogram. Okay, so let us draw a parallelogram. Let's say this is a parallelogram. Suppose A, B, C, D is a parallelogram. As you know, in a parallelogram it has four angles: angle A, angle B, angle C, and angle D. Right? Now we have to draw the bisector of angles. Since there are four angles, now we have to draw the bisector of each angle. Right? So if this is the angle A, now we have to draw the bisector of this angle A. Okay, let's say this is the bisector of angle A. Okay, similarly it is the angle B. Let's say this is the bisector of angle B. Okay, done. Similarly, let's say this is angle D and this is the bisector of angle D, and this is angle C. Suppose this is the bisector of angle C. Okay, so here we have drawn the angle bisector of each angle. Okay, let's say this point is your angle M, this intersecting point is your angle N, this is angle O, vertex O, and this is vertex P. Okay, so O, M, P, N. These are the intersecting points of the angle bisectors of the four angles of this parallelogram. Now, according to the statement, we have to prove that the quadrilateral that is formed here, as you can see, a quadrilateral is formed. Yes or no? See, ONPM is a quadrilateral, and we have to prove that this quadrilateral is a rectangle, so that the bisector of angles of a parallelogram. This is the parallelogram, these are the angles, and these are the angle bisector of these four angles. Now, after drawing all the angle bisector, as you can see, there is a quadrilateral formed here, and we have to prove that this quadrilateral is a rectangle. Okay, so let us write what is given here. It is given that ABCD is a parallelogram. ABCD is a parallelogram. Now AP is the angle bisector of angle A. Okay, so AP is bisector of angle A. Okay, BO is the bisector of angle B. BO is bisector of angle B. Similarly, CO is the bisector of angle C. CO is bisector of angle C, and DP is the bisector of angle D. DP is the bisector of angle D. Okay, are you clear? Now, after drawing this four angle bisector, we have a quadrilateral inside this parallelogram. Now, what do we have to prove? We have to prove that this ONPM quadrilateral is a rectangle. Okay, so tell me how or which are the conditions should be satisfied to be a rectangle. Minimum condition. The minimum condition is if we can prove each angle of this quadrilateral is 90 degree or to be 90 degree, then we can say yes, this is a rectangle. Yes or no? Yes, because we know in a rectangle each angle is 90 degree. Okay, each angle is 90 degree, and it is also obvious that both the pair of opposite sides are equal and parallel. So minimum, if we can prove that each angle is 90 degree, then definitely it will be a rectangle. Okay, so let us prove it. How we can prove it? So let's prove. Okay, see, since ABCD is a parallelogram, then angle A and angle B are two consecutive what? Angles. Okay. So angle A and angle B are two consecutive angles, and we know the sum of any two consecutive angles is 180 degree. So we can simply write angle A plus angle B is equal to 180 degree. Okay. One thing I have forgotten to write. Since AP is the bisector of angle A, it means this angle is equal to this angle. Okay. So we can write DAP angle is equal to BAP angle. Okay. So we can write DAP angle is equal to BAP angle. Then BO is the angle bisector of this angle. So we can write ABO is equal to CBO. Okay. So FBO is equal to CBO. CO is the angle bisector of this angle. So BCO is equal to DCO. BCO is equal to DCO. We can conclude it, right? Similarly, DP is the angle bisector of this angle. So ADP is equal to CDP. Isn't it? Yes. So ADP is equal to CDP. Done. So now what we have proved? We have proved that this angle and this angle, two consecutive angles of this parallelogram, so their sum is equal to 180 degree. You can write the reason here that they are consecutive angle. Done. Next, we will do what? We will multiply half on both the sides. Okay. So half into LHS and half into RHS. So we have multiplied half on both the sides. Now distributive rule is applied here. We will get half of A plus half into B, or half of B is equal to. Now in the right hand side we will get 90 degree. Okay. Now half of A. Since this is the total angle, this is the total angle. So half of A means either you can write this half or you can write this half, right? Because AP is the angle bisector of angle A. So we can write half of A means we can write this angle. Yes or no? Yes, this can be substituted because this half is equal to this half. So half of A means this angle. This angle. So BAP angle. Okay. So we can write half of A means BAP angle plus. Next, half of B. Half of B. Since this is the angle bisector, so this angle is equal to this angle. So half of this angle B can be written as this angle, because this is equal to this, so we can write this angle. So half of B can be written as ABO. Understood? So ABO is equal to 90 degree. Okay. Now it is clear. So finally we have found BAP. BAP, this angle, this angle. See this angle. I have said it this angle plus ABO, this angle, right? This angle. So the sum of this two angle is 90 degree. Done. Next, if we consider then triangle ABM, we will consider which triangle? I am writing here. You can write just below of it. Okay. So for triangle ABM. Okay, for triangle ABM, the sum of three angles, this angle and this angle and this angle is equal to 180 degree. Yes or no? Yes. So this angle means this angle means BAP plus this angle means ABO plus this angle means AMB. Is equal to how much? Is equal to 180 degree. We know it. In a triangle, the sum of the three angles is 180 degree. We know it. So now, as we have proved, suppose this is equation 1. As we have proved BAP, this is also BAP, this is ABO, this is also ABO. Since we have proved the sum of this two angles is equal to 90 degree. So in the place of this two angle, we can substitute 90 degree plus AMB is equal to 180 degree. Is it clear? So what is the value of AMB? So the value of AMB is equal to 180 degree minus 90 degree. So the value of AMB is equal to 90 degree. So what we have found? We have found the value of AMB angle. That means this angle, right? So this angle is 90 degree. We have found out it. Okay. So make a box of it. So we have found AMB is equal to 90 degree. Now just look at this. AP and BO are two line segment like this. AP, this is A, this is P, then BO like this, BO. Now this angle is 90 degree, this angle is 90 degree. Then could you say what will be the value of this angle? It must be 90 degree. Why? Because these two pair of opposite angles are vertically opposite angles. So if it is 90, then definitely this angle, it means this angle must be 90 degree. Carefully look at this. These two are straight lines. They are meeting each other at a common point M. Then if this angle is 90, then definitely this angle must be 90 degree because they are vertical opposite angles. So we can write hence this angle must be 90 degree. So this angle means angle OMP. So angle OMP is equal to 90 degree. Why? Because these two angles are vertically opposite angle. Okay, you can write the reason. Why? Because since this angle AMB is equal to OMP are vertically opposite angle. Understood? So we have found that for this quadrilateral OMPN, okay, for this small quadrilateral, this angle must be 90 degree. Understood? So now it is proved. Let's say this is equation 2. Okay. So the same procedure is again followed here in order to prove that this angle must be 90 degree. Okay. So in order to prove this angle 90 degree, what we have taken? We have taken A plus B is equal to 180 degree, right? These two angles is 180 degree because these two are consecutive angles. So similarly, we have to take that angle D and angle C. Angle D and angle C, okay, is equal to 180 degree. Similarly, same procedure is followed, right? Then what do we have to do? We have to multiply half to this side and to this side. Then what we will get? We will get half of D, here half of C, and this one will be again 90 degree. Okay? So half of D means, since this is the angle bisector, so half of D means we can write this angle. Okay? Similarly, half of C means this is the angle and OC is the angle bisector, so half of C means we can write this angle, isn't it? So we have proved that this angle plus this angle is equal to 90 degree. Similarly like this. Okay. Next. Again here also you have to consider the triangle this NDC. Okay. So in this triangle, this angle and this angle are added to give 90 degree. It means this angle must be 90 degree. Clear? So if this angle is 90 degree, then definitely this small angle must be 90 degree because they are VOA, vertically opposite angles. So here we have to prove that yes, this angle must be 90 degree because this is 90 degree. Okay. So by taking D plus C is equal to 180 degree, we can find that this angle must be 90 degree. Okay. Initially we have found that this angle is 90 degree. Now we have found that this angle is 90 degree. So you can write it. So after writing this, we have to write here, there is no space, so I write here. Similarly, okay, this angle O, this is N, right? This is N. ONP is equal to 90 degree. Okay, ONP angle is 90 degree. Similarly, if we consider again this angle and this angle, angle A and angle D, angle A and angle D, these two are also consecutive angles, so we can write this must be 180 degree. Then same procedure is applied as like this. We have to multiply half on both the sides, so that we will get this. Yes or no? Yes, definitely yes. Now half of a means we can take this angle. Yes or no? Yes. Half of D means we can take this angle. Okay. Now for the triangle APD, carefully look at this. For the triangle APD, this angle plus this angle is 90 degree. It means this angle must be 90 degree. Why? Because in a triangle the three angles sum is 180 degree. If any two angle is 90 degree, then this angle must be 90 degree. So here we have found that this angle is 90 degree. Okay. So we can write similarly this angle MPN is equal to 90 degree. Are you clear? Okay, you have to write like this. Okay, do not try again. You have to prove that this is equal to 90 degree. No. Simply you have to write similarly this is equal to 90 degree, this is equal to 90 degree. But you have to understand how and why it is 90 degree. Do not write it, but you have to understand it. Again you can take that this angle plus this angle also 180 degree because they are consecutive angles. Angle B plus angle C is equal to 180 degree. And same procedure is also applied here as like this. You have to multiply half here, half here, half here. So half of B, half of C is equal to 90 degree. Right? Half of B, this is B, half of B means you can take this angle. Half of C means you can take this angle. So sum of these two angles is 90 degree. Now if we consider OBC triangle, right? In OBC triangle, the sum of any two angles is 90 degree. It means the third angle must be 90 degree because the sum of three angles of this triangle is 180 degree. So again we found that this angle's value, angle O, right? Angle O means MON is also 90 degree. Okay? So you can write similarly angle O means MON is equal to 90 degree. Okay, so what we have found finally? So we have found that in this quadrilateral ONPM angle is 90 degree. OMP means this angle is 90 degree, this angle is 90 degree, and this angle is 90 degree, and this angle is 90 degree. It means in this quadrilateral all the angles is equal to 90 degree. That means it is nothing but a rectangle, because in a rectangle all the angles are 90 degree individually. So here also we get that all the value of interior angles is 90 degree each. So you can write hence ONPM, right? ONPM is a rectangle. Hence it is. Okay, do you understand this? Why we found that each angle is 90 degree? You have to follow this procedure in order to find each angle is 90 degree. Then it will be a rectangle. Okay, it is clear. But you have to just remind this statement. Do not forget this statement. You have to remind this statement that in a parallelogram, if we draw the angle bisector, then in the center they will form a quadrilateral, and this quadrilateral must be a rectangle. You have to just remind it. Okay, in some examination point of view, short question may be asked that if we draw the angle bisector of a parallelogram, then the quadrilateral form is dash. You can write yes, it is a rectangle. Okay, similarly in example number 4, in this previous lecture also we have discussed that if there is two parallel lines, then there is a transversal line, right? Then the angle bisector of each interior angle formed, okay, then they will form a quadrilateral. Then this quadrilateral is also rectangle. You have to also remind this statement. Okay, so we have completed example number 4 and example number 5. So in the next lecture we will discuss about another theorem, that is theorem number I think 8.8. Okay.